Step in this bitch, my shit bumpin'. She told me she don't wanna have no kids, so she dick suckin'. I kill these motherfucking verses like Ted Bundy or Rich something. I make it internet rapping, I'm rich off it. I got like 20 more episodes of Rule 34 binge watching. My shit poppin' like alleys of fireworks lit off on the 4th of July. Off it like
got off the wires. When I close my eyes, disconnected and tired. I see you. I see you, yeah. And I know you keep asking me, flames and fire. I know you are done with me. It's just fired. It's just fired. I was wrong, but I made it right. You came begging day and night. I don't wanna hit the bottom. Don't go out of your state of mind. I've been counting 1 to 10. I'll be back when you be dim. With my music again and again. I see you. Yeah, I see you go down. Yeah, I see you go down. I see you. Yeah, I see you go down. Yeah, I see you go down. And I know you keep asking me, flames and fire. I know you are done with me. It's just fired. I see you go down. Yeah, I see you go down. I see you go down. Yeah, I see you just fired. Fire. I know you keep asking me, It's shots fired.
I wanna know your dark side. I wanna know your secrets. I wanna be your lifeline. So I wait for you, wait for me. Wait for you, wait for me. Tell me you're more than just a highlight. Pretty pictures on the outside. I hate to stare at you through these lights. So I wait for you, wait for me. Wait for you, wait for me. Click and scroll, I can't let you go. They say I'm addicted to you. Click and scroll, I can't let you go. They say I'm addicted to you. Oh, oh, this ain't love, no, no. This ain't love, no, no. This is artificial. This ain't love, no, no. This ain't love, no, no. This is artificial.
I wanna know you inside and out. Wanna know what's behind the light. Wanna feel that real love from within. In the end, I want real love, real hearts. You're just enough to get me through, get me through. 'Cause you're officially perfect for me. So wait for you, wait for you.
Up all night thinking, passing the time, anxiously waiting. You're mine, losing and winning. You can't get it right. Hoping you see me from more than just nights.
Up all night thinking, am I on your mind? Will you come meet me and change my life?
This love could be deeper. Just
Thinking, will you love me?
click and scroll, I can't let you go. They say I'm addicted to you.
Addicted to you.
Click and scroll, I can't let you go. They say I'm addicted to you. Oh, oh, this ain't love, no, no. This ain't love, no, no. This is artificial. This ain't love, no, no. This ain't love, no, no. This is artificial.
Round and round we go, losing self-control. I keep telling myself, but I don't wanna let you know. Is this what we become? Strangers on the run, looking for something, chasing the sun. All those days trying to find a place where you'll make them just be alone, be alone. All those nights lying by your side, like a survivor, feeling it shine under your spotlight.
Shut
That's the way every day goes. Looking back, I know we started falling. We were falling in love, yeah. Took my heart and you rode off. Was I feeling never enough for you, baby? When you left me chasing you. Chasing you. Trying to find a place where we can be alone. All those nights lying by your side, like it's a vibe, feeling it shine under your spotlight. Place where you won't let them just be alone. Like it's a vibe under your spotlight.
Hey guys, thanks for watching Cheap Shot. We're going to do another video going over a little bit of Fusion 360 for anyone uninitiated. So just out of the bat, there's a few people in the chat. Do we have anything that you guys want to see before we just kind of roll into it? And just kind of do some simple shapes and kind of figure out the way of the land for getting anything done. Go ahead and type that in the chat, but we'll kind of just get started talking about Fusion 360 a little bit. Everything kind of works, you know, here in this sketch plane. So let's just do something, you know, real simple. Let's say we want to make like a cotter pin, right? So we're always going to start with create a sketch. And then here we can select what plane we want to do it on. We can do it on a vertical plane or a horizontal plane. We'll just do this face right here. And the tool that we're going to use for making this cotter pin, I think we'll use the Revolve tool. Now there's a couple different ways, so we'll do two ways that we can do it. The first way is, like I said, is the revolve way. Let's pretend like we're looking at it like it's sliced in half. And so we can come up here and we can basically revolve it around this green line. So we can basically sketch a plane of it and then bring it all the way around. And how that would work is like we can come here at the bottom. Let's say I want the head to be, you know, 24 millimeters thick. For this one we need 12, remember, because we're going to go around to the other side. And we'll say we want it 5 millimeters thick, right? And we can do this using, you know, a square tool. There's a couple different ways we can do it. How big do we want the shaft? Well, you know, we can have 12 millimeters back in. Let's say we want the shaft, you know, 5 millimeters thick. Well, remember we want to go minus 2.5. We want to be a little bit bigger than that. So let's say it's going to be 10. And then we can bring up our total length of how we want our shaft to be. And we can come back in. I don't know what that is. Must be an update. And we can come back in and we can connect everything back up again. So then here we have this L shape. So what do we do with this L shape? We're going to come over here to create. We are going to do a, where's it at? Revolve. Can't find it. Revolve. And it's going to have us select a profile. We already selected that, so it's enabled. If it didn't, we could select up here to profile. We could select that shape. But it's going to be the axis of which we want to revolve it around. And remember, we did it right on that green axis. So we can click this point right here, and it'll file it around just like that. Hit OK. And there's our cotter pin. Now, there's another way we could have done that too. Here on this bottom base, we could have used this circle tool, and we could have made the head of our pen, right? That could have been done too. And then we could have extruded that up 5. And then on the top of that, we could have done another point. And we can extruded that all the way up as well. That would have been perfectly fine. We could come up, 20, however high we want. We could extend to an object, and we can set it to that plane so it's the same height. We can do all that. But it's just 2 different ways to skin a horse and make the same object. Just 2 different ways. Now, the way that, depending on how you're designing it, will be the etiquette of which would be the best way to do it. For most of us, it doesn't really matter. You can do more extensive shapes, like a family member of my fiance just sent me a guy had made a lightsaber. So one thing that we can do if we're making a lightsaber is we can kind of have, the base of what we want it to be. So this will be 20 millimeters thick. And then you can really just kind of, freeform it. You could come in, you can make all sorts of shapes if you wanted. Make, whatever you want. And that could be his lightsaber, if that's what he wanted to design his handle with. And it would just be the same thing. We can revolve that all the way around. So let's say he did want this to be his lightsaber. It's kind of ugly, but you know what? It works. Sometimes they got like little buttons on it. So how would we get the buttons? Well, we need to make a new plane to draw on. We can either draw on a face or we can draw on a plane. Now, we can't draw on these planes because they're round. It doesn't really work. But what we can do is we can take and we can construct, and I'll show you this, we can construct an offset plane. We can do a mid plane. There's all different ways that we can do it. So we're just going to do an offset plane, and we're just going to offset it from this one just a little bit. And it doesn't really matter. There's other ways we can do that. We'll kind of bring it in. Well, we don't even need to do an offset plane to make this square. We can actually just sketch right on this face, and we're technically in the model. We are inside the model. And we can do our little square for, our buttons. And you can see that that square is actually inside. But that doesn't change anything. We can still come down here and click that. And we can extrude it out. But see right here how it's automatically assuming that we want to cut that. So if I were to hit OK, we could see right in it. We don't want to do a cut. We want to edit this feature, and we want to do a join. So it just comes out and makes a little toggle switch for our buttons, where we can add some buttons of random sizes and whatnot. And extrude those out. If you just joined, please let me know if there's anything in Fusion 360 you'd want to see. I'm just kind of farting around, showing some certain tools. Maybe we'll get some practice items and see if we can make that. Well, let's do a practice item. So we'll just get rid of all this. Like I said in the chat, let me know if there's anything that you in particular would like to see. So we're going to look at this. This is a practice part. If you follow a tutorial or a manual, here's a book there I learned CAD on. You can't really see it because of my thing, but it's Creo Parametric 6.0 tutorial. Creo is the CAD software that I learned how to use. But it's kind of like learning a language or like a coding language. Once you kind of learn one, you kind of learn a whole bunch. So we're going to make this item right here. This is kind of like a bearing, and it'll give you directions. These will be great to follow. So right away, let's kind of minimize this so we can keep it on the screen, but I don't think it's going to work. It doesn't matter. Let's make some sort of bearing, right? So we'll make a big circle, and this will be our outside mounting, right? And if we kind of, I closed it. So we can kind of see we're going to make this kind of outside mounting point first, right? So we have our circle. Let's go ahead and let's make this the size that we want. How thick do we want this base plate to be? We'll say 5 millimeters. That works fine. We can come over here in the circle, and we can use our circle tool, 2-point circle, to kind of, pick an area and kind of do how we want our Mickey Mouse ears to come off of it. So we'll say 15, and we'll hit OK. And then we'll take and extrude that. Distance to object. We could do the distance. We know it's 5, but we want to do proper etiquette, so we can do that right there. And we can make our Mickey Mouse ears. So we want this in 4 different locations. We could have measured, and we could have used construction lines, and we could have gone all the way around and made those 4 different locations, but we're going to use a pattern tool, and we're going to use a circular pattern. So the object that we want to take and bring down is this extrusion right here, or this sketch, either or. We'll actually go back and we'll just do the sketch. How about that? So we want to create a pattern, a circular pattern of, maybe it's not going to let us do that. We'll just bring that back up to object. And we'll pattern, circular pattern. So we have our object selected, our axis is going to be this line, and boom, it made 3 little dots. So we want to have 4. We can do that just like that, hit OK, and then evenly distribute those out. Now, if we were to manufacture this, those are not going to hold up very well. So we can use a fillet to kind of come in here in this corner, and we can do it on this side too. Kind of give it some beefiness, have it connect a little bit. We can bring that all the way out, no matter how much we want it. We can make it a thick, chunky boy. Let's say, can we make it 50? And we can hit OK. But that only did it to 1. We can do the same thing. We can hit that fillet. We can circular pattern that as well. Right around. We want 4 of those. C pattern. Compute failed. That's fine. It didn't like that. If it didn't like that, we can easily, it might take a little bit longer, but we can come in and we can select all of these lines. If you're in the chat, please let me know if there's anything in Fusion you'd like to see, whether it's 3D printing wise, whether it's Fusion 360 wise. We're just kind of letting me know what you guys might want to learn. And we can make that thick. And see how I'll do it for all of them. Hit OK. And then boom, then we got that. So let's take and make sure we get some mounting holes going on. This little triangle is telling me I'm in the center of that. This is telling me I'm in the center of that circle that we did before. So we'll do 10. We'll drop it down. We know, this is 5 millimeters, but once again, to object, we'll go down to there. That way, if we ever go back and we change that thickness, that hole will change as well. And we will hit OK. Same thing we did before. If you're noticing a trend, we are going to circular pattern this around the axis 4 times, and boom, now we got a little mounting plate. Yeah, it's pretty crazy. Someone sent me a file the other day in OpenSCAD, which is very coding based. So you would essentially put code in, and I don't know if you code it or it has a user interface, but you would essentially put code like, hey, I want a circle starting at 0, 0. I want the radius to be this, and you literally had to type it out. It was absolutely crazy. I would never bother learning how to do that myself. So what do we got for this? We got some things raising up, maybe to push in a bearing. So let's do the main housing. We'll create a sketch on the surface. And we'll just say, let's do 45. And let's say this main housing is going to come up another 5 millimeters. One thing that we can do to give it some strength is we can use that fillet tool right there on that curve, and we can kind of make it fillet out a little bit in that curve. If you're 3D printing, just remember that 3D printing doesn't like to do fillet curves in the Z direction. So, you know, if you're doing it in the X or Y, it's great, but not the Z. So if we were going to 3D print this, we would actually want to use a chamfer tool. And that would be just a little bit better. So hit that chamfer right there, and it'll be able to print that a lot better. So looking at the part, it looks like it raises up just a little bit more from there, and then a big hole down the side. So once again, we can sketch on this plane. Let's take and let's raise it up just a little bit, another 5. And now we want to make the hole all the way down through it. Now we have a few options for how we want to make that hole. We can sketch on the surface. We can get our circle tool, just like we have been using. And we can come out to the distance, which is 40. And we can do, 40 minus 2 if we want it, 2 millimeters thick. Another thing we can do, and this will be beneficial where if you have a CAD of something you're already using and you want to make like an attachment for it, is called the offset. So we're on this plane right here. I can click this line, right click, come to sketch and offset, and I can offset this exact geometry however I want. So if I want it 2 millimeters smaller, I just hit -2 and it'll make it 2 millimeters smaller. And I can do that with, with any line I really want. So this is kind of, it's not going to do on this one because I'm not on that plane, but I can reduplicate complicated lines. And then I could extrude this all the way down to there, and then boom, I got my bearing. So is it exactly right? It looks, the measurements aren't right. Of course, we're not really working for that, but it looks pretty damn good. It looks pretty close in my opinion. So, that looks good to me. So is there anything else anyone would like to see, or move on to a different part? We'll kind of look through my manual and see if there's anything going on. Let's talk about this. If no one's got anything else, we're going to use a square pattern tool. So one thing that a lot of people do when they reload is they make, little wood blocks to put their shells in that they've just currently reloaded. And if they're going to hold 100 shells, they might, or 50 shells, they might do 10 by 5. So what if we wanted to make our own reloading block? How would we make that? Well, let's make a reloading block. So we're going to take and create a sketch. And then, we're just going to throw out some random stuff. We're going to say this reloading block is going to be 50 millimeters by 150 millimeters. It doesn't really matter. It's up to you. Dimensions don't really matter. We're just kind of showing you how to do everything. And we can extrude this up. Let's say we want it to be 5 millimeters thick. Let's go 10. 10 millimeters thick. So we need to make that grid where we're going to put our reloaded shells in, right? So we want to draw on this top surface, create a sketch, and let's just say that we have this great, you have your line tool, your square tool, circle tool. If you come down to create, you have different types of tools. So one will be good is a 2-point tangent circle, right? So we want it, the line tangent between this one and that one. It's going to take and pop it on there, which, isn't really good. But one thing we can do is you can learn later about construction lines. I hate working with construction lines. I just do the lines and then delete them later. So we're just going to make a grid. Let's say 10 by 10. And then right here is the point where we're going to put our circle. And we'll say it's, 12. We can keep these lines. It's not really going to hurt anything, but I'm just going to delete them. I'm just clicking on them, hitting delete on my keyboard. So now we know it's equilateral distance between both sides. And we can hit finish. And now we need to dig down to make a hole for our shell to be in. So I can take and extrude this, and I can extrude this all the way down if I wanted to. I can extrude it for infinity. But one thing that we've got to remember is that, if we're going to 3D print this or something, well, we need to leave a little bit of distance on the bottom to allow for material. So we're at, -10. We can add 0.2 or 0.8 millimeters just so it doesn't go all the way through. So if I change my view to see hidden edges, you'll see that line doesn't go all the way through. So how do we duplicate this block? Well, we're going to hit that extrusion, come to create, and we're going to do a rectangular pattern. So we have our object selected. That's the object we want to do. Now we need to select directions, and we need to tell Fusion what direction we want each thing to go. So we want it to go not only in this direction, but in that direction as well. And it's going to be how many times do we want this? Well, you can drag it and kind of see which direction it's talking about. And we can see that we got a 3x3. You can change the distance, the total distance you want those three to go by, whether, the distance you want each of them separated by. You can do either of those. That's totally fine. Like I said, we're not really measuring too much, so we're just going to eyeball it. We can fit a lot. Well, that's the wrong direction. We can fit a lot more in here. So it looks like our shell holder can be, that looks pretty comfortable. We can hit OK, and we see that it's duplicated them all in a nice square grid. Is it possible to take a pre-existing picture and making it 3D? Benito asks. Yeah, we can actually do that using what's called an SVG image. Is that kind of what you're referring to? Like if I wanted to put an image on the back side of this? So let's say I made this a little bit thicker. I think this is what Benito is talking about. Let's say I make this a little bit thicker, and I want to add an image to the back side of this. You can download an SVG. That's a type of media file where it basically turns an image into a bunch of lines. So I did this in my other tutorial, so I'll show it again I'm not going to show you exactly how I made that SVG. Just Google, JPEG to SVG converter. That's totally fine. We can click on the surface. We can create a sketch, and then we're going to insert our SVG. And you got to find out where you saved it. I'm pretty sure I had this saved way back here. And here's a SVG file that I made before. So I can kind of move it around. I can scale it, make it smaller so it'll fit. And let's say I want to have this on the bottom of this object. Once I have it in place, I can select in the center and I can raise it or extrude it. Someone was telling me before I did this, I can copy and drag it. Oh, hey, and that works. That was cool. So, whoever told me to do that, thank you. So basically I can take this thing and I can copy and drag around it. And you can do this with any image you want. Just remember, you know what? I don't think that likes that, man. It's not going to definitely like that. Maybe he meant something else. But what you would do is once you have your image, you would go in and you would select inside all these different things, right? So I'd come in and I would, select this, hold shift, select all these, and I would do that for everything down here. But once I have everything selected, I can extrude, and I can either have it raised up, or I could raise it down. Not raise it down, but lower it, cut it in. And there I'll have, an image on my print. So that's really interested. If you want to customize something, you can do that. It's really nice. On here on this, if we were making a reloading shell, we could come over here to create a sketch. We can use our text tool. And we could say this is you know, cheap shots. And you can play around with it as much as you want. Make that 8mm a little bit smaller. You can move it around too. But then once you have that text in place, someone was telling me too, they're like, oh, text is gone. I'm like, text isn't gone. You can extrude that out the same way. We can come all the way out. We can even come all the way in, and we can see how it cuts through all of our holes that we made. That would be horrible to make, but if that's what you wanted to do, that's what you could do. If you were to mill this would be horrible to mill. You'd lose that P. But 3D printing, this would be totally fine to do. So, all right. Does anyone else have any questions? Anything else you guys would like to learn about Fusion 360? What's something you can do? Let's see if I can't find another practice shape that might be good. Oh, how about this? All the time when I'm like looking to do something, I want little bolts or attachments or something, and I know I could 3D print it, and I know I could design it, but I don't want to. McMasterCar. You could import CAD models directly from McMasterCar. So, you know, you can come over here to the website, and let's just look McMasterCar. Let's just find a part they got on, you know, tubings and fittings, right? Let's say, you know, you got some fuel line and, you know, you want a tube, you need a tubing, but you don't want to really want to mess around with it. You know, you can take and find these different fittings. I don't want to do that. I want it to be like something like, yeah, let's say something like this. So let's say I didn't want to go out and buy this or wait for it to come into McMasterCar. I can load this into Fusion and then I can print it. So what I basically want to do is I just want to take and copy this McMasterCar part number. A lot of these products, I can come in, I can insert a McMasterCar component. I could have searched for that component in here, but it doesn't really work too well when going backwards. So use the website, get the part, and then here's my part right here. I can hit product details, and I can come to here and I can hit the CAD. I want the step files. Oh, always do step. I don't care, you know, I don't care what you export it as or what software you're using. If you're going to send someone a file, don't send them the STL unless they specifically want the STL. Send them the step. Don't send them any other file. Don't send them the, you know, the Creo or the NX or whatever file attachment it is. Step. Everything opens step. If your program doesn't open step, it's because it's janky. That's the standard. Do step. I hate it when people send me files and it's not in a step file. Sorry, rant over. But we can take this and we can download it and it'll just bring it right in, dude. And there it is. There's my part. I can send that to the 3D printer and I can make that and I can have that. You know, no, I don't have to pay McMasterCar $4 for it. Now, you technically should. It's not really there. It's more for like in your drawings and whatnot. But it works, and it works fantastically, and I use it all the freaking time. So there's McMasterCar. You can use that. Any other questions? Who wants to see something else in Fusion 360? What's something you've been curious about? Please put it in the chat. Let me know. Let me know. So let's talk about parts real quick. Let's say we make that bolt and then we want to put somewhere for that bolt in. You know, this is going to be our main part, but we can make a new component, you know, and let's say we're going to have a pin, and let's say we're going to have a collar. This is great for, you know, making the pin active. And we'll just come in here and we'll just make a quick pin. No problem, Benito. We'll just make a quick pin real quick. And let's say we wanted to make a shaft that goes beefing up an existing project, thicker walls. Yeah, so St. Trilby asked how to go about beefing up an existing project, thicker walls around pins, etc. We're going to kind of, the tool I'm going to use, St. Trilby, whatever your name is, I don't care. The tool I'm going to use is going to be the offset tool. This will be perfect for you to import a model and then offset those walls because it will follow that contour. So back to what we were talking about, I can now make a collar, and that'll be a separate component. I can still do on these faces, but what you're going to want to do is, you know, I'm going to use this to make a collar so it'll slide in. You can, like I said, you can use this on that same face to beef up the walls. On this circle right here, I'm just going to right click, sketch, offset. That's what you can use to make those walls, is you can offset it and you can extrude it. So if I was going to make, you know, if I was going to make this as, like I said, a collar, I want to offset it, you know, 0.5 millimeters. And then I can make my collar, you know, 0.5, you know, 30. And I can extrude this down. But we can see that these are two separate parts. So if I were to go back here to you know, my total part unsaved, I'll see the two parts. But if I just want to work on the pin, I can do that, and I can hide the collar. I can, you know, work on the collar. I can hide the pin. Another thing is, let's say I'm doing everything and I realize, oh, this collar isn't quite where I want to go. I can right click it and I can actually move it, you know, and I actually want to offset just a little bit. I can do that as well. So that's nice with the two parts. Let's see. Never used 360 or an inventor. What would you say the overall advantage of software are compared to? It's free. It's free. That is the advantage. It is free. And the best part about it being free is a lot of other people are going to use it. You know, at work, we used NX. If I had a question about NX and another engineer, you know, didn't know my question, I was screwed. I was, you know, it's like when I learned on Creo, you'd have to buy the book and go through the book. With Fusion, ask Reddit, ask Google. Someone's going to have that same thing. And, you know, and now they have some constraints. I'm using the education license. Now they have some constraints over, you know, how much you can have, how many active parts you can have. That kind of sucks. But, like, it's just the big thing is it's free. So if you have something else that you enjoy using, you know, it's kind of like, you know, go ahead and use that. I'm not knocking Inventor. I'm not knocking Creo. Well, I am knocking Creo. I hate Creo. I hate the user interface. It's just, this is just super nice and clean. Another thing, this is Inventor. This is from Autodesk. This is watered down version. So if you have access to Inventor, just keep using it. Is there a list or standard recommendations for what type, size screws to use? I'm new to them and correct diameters to when I use them. If you're talking about in Fusion, you know, it makes it pretty easy. So I can take and have this shaft, and if I want to thread this part on the pin, I can literally select this outside, create, and I can use this to make a thread. And it'll come up over here with a lot of different, you know, a lot of different profiles and whatnot for what I want. One thing you want to do is make sure it's modeled if you actually want to see it. And then you can come here and you can change your threads to exactly what you want. You can hit remember. And then that way, if I wanted it to thread inside of this collar, I can hit create. I can hit thread, and it'll do corresponding threads. You got to remember, though, that that's corresponding when you're talking about machining. If I were 3D printing that, I would want these slightly undersized, these slightly oversized, just to allow for those tolerances. But threads, you know, make it super easy. And then, you know, if I wanted to show someone, you know, you, of course, can bring that in, and it'll just kind of lock in. What parts or accessories are easiest to start learning? Like I said, you know, you can really, if you get a book, you don't need a book, but it really takes you through very simple things. You know, I had to learn this in school. So, you know, you start off with just basic shapes, and dimensions didn't really matter. It was just using the tools and the shapes. A lot of times you can find another tutorial where there'll be some weird shape and you have no idea what it does, but it's basically walking you through all these different things. Just, you know, search something and try and make it. So, like, you know, a practice CAD shape. You know, the dimensions don't really matter. It's just using the tools to make it. So, you know, like something like this, we can make this the same way, and we can, you know, extrude it down. We could revolve this. This could be used, you know, a couple different ways. You know, it's really, you know, easy shapes like this. Just get started. Just kind of get working. Maybe even measure something you have in your house, and kind of work from there and kind of see if you can make it. There's the teapot. That's famous. It was like a visual thing, and now it's become famous the world over. Look at this. So he's kind of got this shape right here. Let's talk about how if we had like a gear like that. So let's make that gear. Well, a gear. You know, I'm not saying this would be a gear, but like a bolt face, you know, so we can have the gear be 50, and this is just, you know, this is very rudimentary. I actually downloaded a gear creator for a project. It never really worked. Don't tell the professor who graded it, because he assumed it worked, although it did not. For rectangle, we use a center point rectangle just because it kind of gets both sides. And that looks right. Doesn't really matter. We can extrude this out to object to make it the same thickness. That way, if I come in here and I change the thickness, I made that original circle instead of 5. Let's say I wanted it to be 12. That came with it. Versus if I had done just 5, it would not have come with it. So I can get this tool. Whoops. I can get this little tooth, and I can circle pattern it all the way around. So let's say I wanted to make something that would fit around this, you know. This I would want a different, you know, a different part, a new component. But I can click this face, and like I had just shown you before, right click, sketch, offset, chain my selection, and it did it all. And so now I can take and make an outside for it, and then I could extrude that out, and boom, it can slide in and out of there. That is something that might be useful too, if kind of what we were learning before, using like an image. You know, you could outline the image and do that as well. So, does anyone else have any questions for Fusion? Throw it in the chat. You can do a little thing, animation. These are actually kind of fun. It's kind of hard to learn, but you get the hang of it, and then you can take and make neat little videos if you want to show off your part. You can also render it. You know, I can say, hey, I want this part, you know, I want this part to be made out of wood. So, I don't know, let's say, you know, peak. And then I want this part to be made out of, you know, I don't know, mahogany. You know, and that's good for showing off. It kind of comes back. I'm using the wireframe. I really like that. But if you're using like shaded, you kind of see it a little bit more. You know, you can CAD on this as well. I'm a big fan of just wireframe. I think it looks clean. My grandma's calling me, so we're gonna take a quick little break real quick while I talk to my grandma. Hello. Sorry about that, but grandma takes priority. I hope you guys understand that. So, oh, it looks like we lost everyone. That's all right. If is anyone here, if there's anything else that you'd like to see, let me know. Let me know. We'll give it a look-see. Yeah, I'll probably kill it. So if there's anything that you want to see in Fusion 360, down there in the link, there's my Discord. You can go ahead and join that Discord and not live. You can go ahead and join that Discord. Would you model something for 3D printing that can move in one piece? What do you mean move in one piece? Like you print in place and can move. So kind of like you know, like a tweezer or something. Something that, or I forget what they're called, like fluid designs. I guess I'm not really sure what you mean. Or like the Flexi Rexy. So, I mean, you could really print where you print a gear cube in one piece. And they can move without being stuck to each other. So, yeah, that I don't really know too much about how they make that work, but let's give it a shot. Let's make it so if you've ever seen the toy where you have like a square with like a circle in it, let's try and do that. I think that'll be a good challenge. So let's start off with our square, right? And we'll just make that 100 by 100. And we will extrude that 100. So we have 100 cubed square. And then let's take, and how will we make a circle inside of it? Well, we can hit a sketch and we can sketch on a midplane. So that works. Let's do that. So let's take, and we're going to make a midplane between this face and that face. And let's sketch on that midplane. I wonder if we could just do a circle. So let's say our chamber is going to be 90. I wonder if that'll work. I don't think it will. I don't think it will. This is a challenge. Can we revolve that? No, it doesn't like that. So let's take and do it like this. And then we can take and we can make an arc. Whoops. Arc. Center point arc. Can we revolve that? No. This is a difficult one. Why don't I extrude this? Just... Well... Alright, basically, like, you know, they're making something inside of it, but they're using that offset function to make room where they're not going to have material. So you need to make sure that your offset is going to be thicker than any single layer line to allow your 3D printer to then skip over that. Something is like also, you know, something might need to break off in order to kind of support this. So if I have this cube and let's say I wanted to print this inside of another cube. Right? So let's say I had this inside this other cube. You know, I could print that, you know, just as is, facing like this. Of course, it's going to fail because that's going to break off. But I come over here to this bottom face, and I want to take and make sure I see my hidden edges. You know, you could come in and just make little circles that'll kind of just break off, just to kind of support it. Now, it won't really work too well because this is flat. So if you find me a design, Creek Rocker, I can do that a little bit better. So yeah, so find me one of those. Print a gear cube in one piece. Yeah, make sure you're looking. If you're looking, I look too. So let's do Thingiverse. I thought you meant something like this, where it like flexes. Oh man, no, that, if you're talking about one of these, like if like where it kind of moves around, like, oh, that is above my my pay scale, man. I don't think I'd be able to do that right now. I could, but it would take me a while. Let's see if there's anything in here that looks good. How about making this? While you try and find an example, let's make a door clamp, huh? So, well, I don't know. If you guys want to see a door clamp, let me know if you find an example. If there's anyone else that has anything they'd like to see, let me know. Or any help with Fusion 360. We'll be here another 10 minutes. Let's see any tools that we want. Here's the thing. We'll just kind of look at some of these. You have things like lofts and sweeps. So like, let's say we wanted to make like a vacuum attachment, right? We wanted to go from a square vacuum to, you know, a circle vacuum. That's something that a lot of people would use. So, you know, here's our square attachment. You know, we'd want that to be the outside. And then we can construct an offset plane. You know, how far up do we want the adapter to be? 40. And on here, we can make our, you know, circle attachment. And one thing that we can do is we can come here, and it's called a loft. We can hit this profile and that profile, and it'll join them. And we can use that for making our adapter. I just use the gear thing as an example of manual model stuff that a pin can rotate in a hole and be retained. All right, so you're kind of like what we were talking about with this cotter pin, huh? So like, you know, you can 3D print both of these pieces. I guess what we can do with that is let's undo these threads. And let's pull this collar back down. One thing that we can do is see how these are even? Like, we want to bring it so that this piece is just barely up above from the other pin. So if you look at like Fusion, I've got a layer thickness of 1.12. So we want to make sure this is 1.12 above. I can actually construct an offset plane. What was it? 1.12? Am I dyslexic? Yeah, 1.12. Away from that. And making sure I have my pin selected. Oh, I didn't carry over. But I can then make, you know, a new end cap. And then I want to extend this to object. Oh, it disappeared. Well, basically I would extend that pin all the way over, and I can take and move these as well. You just want to make sure that it's separated by a width greater than your layer line. Now it's still going to kind of be tricky. It's going to take a lot of like trial and error. You know, another thing that would probably be better would be just to print it in 2 different pieces, and then you can glue it. That'll work. But I mean, unless you have a need to print this in 2 separate pieces, it's not really worth it. And I messed up because I didn't do this right. But you know, it's not really worth it. You'd rather just glue it. So, all right. I think that's going to be it for tonight. So if you have any other questions, please join the Discord, and I'll try and help you as much as possible. Make sure you like and subscribe. I'd very much appreciate it. And thanks for watching Cheap Shot, guys.